Friend, welcome. If you want to play with recursion, Haskell is a good place to go. Okay, let's play some basic recursion implementations in this video. Let's get started. So GHCI Haskell interactive environment. Okay, so Control L to clean up. Let's start from the very classic one, factorial. Okay, so factorial, 5 factorial, right, is same as equals to this, right? Let's implement this one, factorial, like 5, right? We'll get 120. So this is the function type. F is int, right? Map to another int. Okay, so the base case factorial of 0 is 1, right? And the recursive case f n factorial of n equals n times factorial of n minus 1, right? So like if we know the factorial of 4, we can use that to calculate the factorial of 5, right? 5 times factorial of 4, we'll get that. So that's the recursive case. Okay, that's it. So now let's test it. F0, F1. So F0, you will use this base case. F1, it will go here, right? F1 equals 1 times F0. So recursively, the code will call the function itself and arrives here. F0, 1, and going back 1 times 1, so it's 1. Now F5, yeah, so done. Next one, let's try to implement the multiplication of integers. Okay, so for example, 3 times 5 is like that, right? So let's implement this function, our own, right? So that multiplication m is 2 integers, right? 2 integers multiplied together to get another one. Yeah. So what is the base case? Multiply x and y, right? The base case is like that. So we'll base this algorithm on the fact that multiplication is no, let's use, oh yeah, so x times y, for example, right, is like we'll add x y times, yeah. So one time, of course, x multiply times x times 1 is x, right? And then what if x times y equals is y, right? No, it's x plus multiply x and y minus 1. So eventually this guy will be 1. Okay, so that's it. Let's give it a try. So multiply 3 and 5. Okay, multiply 5 and 3 is that. So how can we use the infix, like put the m, right, the operator in the middle of the two operators, operands, we can use the backtick, right? Haskell can use this syntax, m, like backtick, right? 3, yeah. So 3 multiply 5 Okay, done. So next, let's play with the recursion for list. Okay, so what is list? This is a list, right? Like that. This is a list, and there's a system. There's a library function product. For example, yeah, if we multiply all the 5 numbers here, we get the 5 factorial, right? Like that. So how can we implement this product thing? So it will do, right? It will multiply each element inside this. Okay, so let's provide another example. So 2 times 3 times 2 is 12, right? How can we implement that? So let's define our own, right? Product. The data type is, so the input is an here is a yeah, I think that's defined so this is a class. The class is number, so the A type A, right, belongs to class number, and the signature is, the function type is like an array of A mapped to A, right, a number. Okay, so how can we define the base case here? Base case, so it means if it's an empty, product of an empty list is 1, right? And product of number, okay, so let's use X. This is a, right, how we put the pattern of a list. If this is a empty list, this is the pattern, right? X cons XS, this is a list, sublist, this is its element. So this one equals, right, X times product of XS, right? So the function application has the highest priority. So this expression will do this first, then do the multiplication. Okay, now let's try that. So instead of this one, let's use our version P, right? 12. Cool. So what about the factorial? Nice. So this is our version of product. And what about the other, like decimal number, like for example 0.5, right, and 2 and 5? So it will be 5, right? Yes, 5.0. Okay, next let's define the length. This is also another, right, library function. The length of a list, how can we implement that? Using our recursive idea. And okay, let's do it. Let length is a list. Okay, so a list of A map to integer, right? The length of it. Okay, so what is the base case? If it's empty, then the length of it is 0, right? So this is L, not the 1. L, okay? Now what it's the recursive case. So recursive case, we don't care what it is, like that, equals 1 plus L of the sub list, right? So this is 1, and this is our length L, okay? Because we don't use this one, so we can use the underscore for the placeholder. Or yeah, does it work? So let's go back to this one. Let's use our own implementation. Length of the list from 1 to 9 inclusive 9. Yeah, so L of empty 0, right? L length of like a single, yes, a single element. That's great. Okay, what about another one, like reverse? So how can we reverse this one? Reverse, yeah, how can we implement that using recursion? Let's define one, right? Reverse of, no, a list will output another list, right? The reversed version, okay? So what is the base case? Of course, it's empty, right? The empty one is still empty. Now what if it's like that, x and substring, right? The head x and the sublist. So we want to put the x to the at the end, right? So it will be reverse of the sublist, right? Concatenate it with a list with a single element, right? So for example, say we already have that reversed, then we only needed to put the 9 at the end of that, right? Yeah, that's the recursive case. Okay, so I think we need a parenthesis here. Let's do it again. So let, this is the base case, this is the recursive case. Yeah, like that. Oh, what is wrong? Oh, here, sorry about that. This guy, yeah, this is okay, let's try it again. Sorry about that. So this one is equals, yeah. Then the recursive case, do we need these parentheses? So this one R will accept that. I think we don't need that, but let's try this first. Okay, so now reverse, right? 1 2 5, yeah, it works. And what about the empty one? Okay, now let's try to remove these parentheses. Okay, I think it should work because this one has, right, this one the application of function has higher priority. But yeah, let's see if I'm wrong or correct. So let's remove this one to see if it compiles or not. Yes, right? So that's the the best way. Yeah. So R 42900924. Great. So you see, playing recursion using Haskell is so much fun, right? Thank you for watching. See you next time.